right, so this section is on derivatives of inverse trig functions. Okay, so again, on the test, I give you these formulas. So that's about the only formulas that I give you, but I will give you these. Here are the formulas for the derivatives of all of the inverse trig functions. So really all you got to do is just follow the formula. Notice, for instance, this first one we're taking the inverse sine of x. This is the derivative, right? So if you have something in the place of x there, some other function of x in there, remember chain rule still applies. So you still would follow this formula, but then you would multiply by the derivative of whatever x was. Okay? All right, so let's do a few of these. All right, so first, let's say that we've got f of x equals x times the inverse sine of x. Okay? So again, all of our rules of differentiation still apply just like it did before, right? So notice I've got the product of x times inverse sine x. So if I've got a product, I need to use the product rule. So product rule, I would say the first times derivative of the second. So x times the derivative of the inverse sine of x is right there. So I'd say times 1 over square root 1 minus x squared. Right? And then plus the second times derivative of the first. So the second is inverse sine x. The first derivative of x is 1. So this would be just plus inverse sine x. Right? All I did there was just multiply these two together. So the derivative is x over root 1 minus x squared plus the inverse sine of x. Right. Questions about that? This is actually chain rule, right? Because we've got a function inside of another function, right? What is the main outside function here for this? That's the big outside function.
Inverse sine.
Inverse sine, correct. All right. And then inside, you got e to the sine x. And then on the inside, you also have a function inside a function, right? You got e, and then inside that, you got sine x. So we've got three things going on here, right? So start with the biggest one on the outside, which is the inverse sine. So the derivative would be, all right, inverse sine is this. So it would be 1 over the square root of 1 minus, and now it's x squared, right? So what is x here? Well, x is e to the sine x power. So be sure you put that inside the parentheses here. Right, just like that. Okay. And we'll multiply that times the derivative of the inside function. All right, well, the inside function, the big function on the inside there is e, right? What is the derivative of e?
E.
Just e. So times e to the sine x power. And then inside of this, you got sine x. So I got to multiply by the derivative of sine x as well. What's the derivative of sine? Cosine. So times cosine x. So that's the whole thing multiplied out there. Any questions about that? All right, so all I did to reduce that is just move this up here on the top. So my answer then, e sine x cosine x over square root 1 minus, and if you've got a power raised to a power, you just multiply, so that would be e to the 2 sine x power.
All these on the left side you said are going to be on this. Oh, we're going to have that on the
You have those on the, yes. So on the review on the test, I gave you all of those, and the derivative for a base exponential other than e, and then also logarithm with a base rather than e. So I do give you those two as well. Okay, so we're going to do the derivative. All right. Again, just follow the formula there. Here is the formula for tangent, inverse tangent. So it's 1 over 1 plus x squared. And notice in the place of x here, inside x, I got 10x. So I'll need to put 10x, and then that's squared. Okay. Again, always use chain rule of differentiation. Right? So I have inside that inverse tangent function is a function of 10x, right? So I got to multiply by the derivative of 10x. What is the derivative of 10x? 10. So times 10, that is 10 over 1 plus 100x squared, and that is all you can do to that. All right, questions about that? So the derivative, okay? Well, anytime we're doing derivatives with radicals, it's best to write those with exponent, right? So square root z is the same thing as 1/2 power. All right, so now let's use our formula here, and notice here we have two functions. We've got the inverse cotangent, that is the big function. So we do it first. The inside function is z to the 1/2 power. Okay? So derivative of f is cotangent is just really the negative of what inverse tangent was. So it's negative 1 over 1 plus x squared. So I will take z to the 1/2 and square it. Okay, so that's the derivative of the inverse cotangent part. The derivative of z to the 1/2 power, I use the power rule, so I would say 1/2 z, subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. So now I just need to go negative 1 over 2. And then the z to the negative 1/2, let's write that as square root z times 1 plus, and now 1/2 times 2 is 1, so 1 plus z. That's our left answer. All right, any questions about that? All right, so the first one. All right, what is the big outside function on this one? First one. What? 2. The power of 2, right. Okay, so on the ones we did before this, the outside function was the inverse function, right? Whatever the inverse function is. Here, the inverse function is what is on the inside. So you've got to do this power of 2 first. We do the derivative times the derivative of the inside. All right, so power rule, I'll say 2 times that. Subtract 1 from the exponent and I get 1. Multiply times that, the derivative, I changed that, didn't I? Multiply by the derivative of the inside, derivative of cosine is negative 1 over square root of 1 minus t squared. That's it. All right. You probably want to put those together, so you just write them as one fraction. Negative 2 inverse cosine t over root 1 minus t squared. Okay. Any questions about that? This one, what is the outside function on this one? What's the outside function on this one? ln. Inside is inverse tangent. All right, so what is the derivative of the ln? Remember that one. 1 over x, right, correct? So here it'd be 1 over inverse tangent. So I'd say 1 over inverse tangent of t, but then I got to multiply times the inside, which is the inverse tangent of t. So the inverse tangent of t is 1 over 1 plus x squared. Okay? So that will be just 1 over inverse tangent t times 1 plus x squared. Okay. I got 3 more here. We got to try these on your paper before I do. Okay, so I'm trying to try to practice these. right, here we go. All right, look at the first one. On the first one, what is the outside function? Is it the e to the 4x or the inverse tangent?
Inverse tangent.
Inverse tangent. So I need to start with that. So inverse tangent, so derivative would be 1 over 1 plus x squared. Well, x is e to the 4x here. Let's do that, okay? The inside function then is e to the 4x, okay? So the derivative of e is just e, right? But I don't just have x up there, I have 4x. So I can also multiply by the derivative of 4x, which would be 4. So I have 4e to the 4x over 1 plus e to the 8x power. All right. Questions about that? All right. This one, what's the outside function on this one?
I happen to do have a question about the one above that.
All right.
Would it not be the, never mind. I'm good.
Okay, all right. All right, this one, outside function, outermost, inverse cosecant. Inside, you got tangent and e dx. So inside, tangent would be outside of e dx, the innermost. So 3 different functions here inside of the other. So, all right, so cosecant, inverse cosecant is that. So we would say negative 1 over the absolute value of x. Well, x here is tangent e to the x. So I need to do the absolute value of tangent e to the x, and then times the square root of x squared. So again, x is tangent e to the x minus 1. Okay, so that would be the inverse cosecant part times the derivative of the inside. All right, what is the derivative of tangent? Secant squared. All right, got to remember that. Okay, secant squared e to the x. But then inside of it, I've got e to the x. What's the derivative of e to the x? E to the x. There you go. Okay, so I wrote my answer as, if I put all this over here, negative e to the x times secant squared e to the x over absolute value of tangent e to the x times the square root of. Now, notice here this square on the tangent e to the x, that is the tangent e to the x is what's squared. So it would be all right for you to write the square right there after the, on the end, the tan part there. So tangent squared e to the x is 1. All right, any questions about that? Okay. All right, last one here. F of s equals inverse cotangent e to the x. All right, so the derivative, all right, the inverse cotangent is negative 1 over 1 plus x, which in this case is e to the s power, times the derivative of the inside. Derivative of e to the s is just e to the s. So that was pretty simple there. That would be negative e to the s over 1 plus e to the 2s power. Okay. Questions about any of those? So that's your inverse trig functions, the derivatives, and basically you're just following a formula. You still use chain rule like you learned. You still use product rule, quotient rule when needed. Okay, so the same rules apply. And then the point is 2 pi over 6. So we want to know what is the tangent line to the graph at the point 2 pi over 6. Okay, so let's find our derivative because we've got to have the slope in order, slope of the tangent line in order to write the equation. All right, so here the derivative, the big function is the inverse sign, so it's 1 over square root 1 minus x squared, so x over 4 squared. But then times the derivative of the inside. X over 4, the derivative would just be 1/4. Okay, so 1 over 4 times the square root of 1 minus x squared over 16. And I wouldn't do anything else to that. Really no need to, okay? Because we're not finding the derivative, we're just finding the slope, we're just finding the tangent line, equation of the tangent line. So, all right, so here let's put 2 in for x. Okay, so I'll have 1 over, because 2 is the x value there where I'm pointing to the tangent line. So that'll be 2 squared over 16. All right, so that will be 1 over 4 square root. All right, this will be 4 over 16. This is 16 over 16. So 16 over 16 minus 4 over 16 is root 12 over 16, which is root 12 over 4. Your 4's cancel. So you have root 12, which will reduce to be 2 root 3. So I got 1 over 2 root 3 as the sum. Okay. Don't worry about rationalizing the denominator. Okay. Questions about that so far? So that is my slope of my tangent line. Okay. So if I want to know what is the equation of the tangent line at that point, then all I do is just start with point slope form. And then I just fill in the numbers here. Y minus the y value equals the slope. X minus the x value. Okay. That's probably fine. You could distribute that, kind of get it more of a slope-intercept type form. You would just have y equals 1 over 2 root 3 x. And then 1 over 2 root 3 times negative 2 is negative 1 over root 3. And then add the pi over 6 to both sides. That would be the equation of the tangent line of that function at that point. Any questions? That is inverse trig functions. Good.